Hello, welcome to Mining Now. I'm your host, Jared Downey, and we are back filming another episode at Mine Exchange by SME in Salt Lake City. We're having a great show here. We've got a lot of new companies coming on, and we have companies that have been on. In this case, this is their fourth episode on Mining Now. We've got Austin Powder. Very, very excited to have two new guests. The company's been on. You gentlemen have not.
No, we have not.
That's right.
Okay, we've got some. We've definitely got some new technology to talk about on the show. We are just going to cover, just for anybody who hasn't seen, about what Austin Powder does. But let's make an introduction first. We've got Campbell Robinson, Global Manager of Electronic Initiation Systems.
Yeah.
Right? Do I have that close?
That's right, Jared. Exactly correct. Yeah.
And then Mario Julio Alcedo?
Yes,
Alcedo, sorry. Global Director at Austin Powder.
Yes, sir.
How long have you both been with the companies?
So I've been with Austin Powder since September of 2019. So coming up on 7 years now.
Yeah.
I've been with Austin 29 years. In different.
That's a while.
That's a little bit. In different roles and the business, managing a business in Central America, out of Panama, and in the past 3 years in my current role as Global Director for Field Services.
I feel like with seniority, I'll ask you to do the company intro.
Yeah.
I feel like you'll know.
Yeah, different way of calling me old. Yeah.
My young staff now thinks I'm old, so it's all perspective. So, Mario, could you just give us just the bird's eye view? Who is Austin Powder for anybody who doesn't know?
Yeah, Austin Powder is the oldest explosives company in the world, founded in Akron, Ohio in 1833.
1833.
194 years, I believe.
What? That's crazy.
Under the same name, under the same structure we have today.
Really?
So for over 150 years, we were basically a company servicing east of the Mississippi River. We serviced the very large coal mines. We were part of the Industrial Revolution in the United States when coal was discovered in West Virginia, Pennsylvania, Ohio, and then all the steel mills were built in Pennsylvania. We've been around as a company, and since then we've grown into the different industries in our business, the quarry and construction business, and of course civil construction, whether that is underground or surface.
Wow. What do you think? Do you get a sense of? Actually, I'm going to ask this to both of you because it's going to be interesting having the more experience and then being around. I mean, 2019. That's still that's
Relatively new, yes.
Yeah, but that's still 7 years or so?
Coming up in 7 years.
Still
That's
quite
right.
a while. What do you think separates the client out, or separates Austin Powder out from competition?
Well, I think we're very customer centric. We are a large enough company, but also small enough to be customizable. We do a lot of work with our customers to ensure that we can customize our service offering to their needs, and as I said, large enough to take on the bigger projects, the bigger companies. So our manufacturing footprint, as I was saying, I'm going to step back. As I was saying, for 150 years, we were just in one part of the United States.
Yeah.
And then we started venturing internationally, even before going west of the U.S. We started going to Chile, we went to Czech Republic, and from there we expanded our footprint in Latin America, Europe, and most recently Southeast Asia, in Africa. But west of the United States, we also had some operations, but not very active, where today, in the past few years, we have a bigger presence, and we're looking to grow our company out west.
Was it a growth mentality when you joined?
It was a slow growth mentality back then. That's a good question. We grew with very solid steps, very slowly but very solid. We made very strategic investments way back then in vertically integrating raw materials. Today we have a different perspective and mandate for our growth
And are at the size and scale to fulfill that mandate.
Absolutely.
Exactly. Yeah.
Absolutely.
Yeah.
The checkbook is there to invest, and we're investing heavily today in LATAM, in the U.S., in Africa. Those are our main points today.
What's exciting, Campbell, about the day-to-day here? I mean, we're going to talk about some products that you've rolled out now and that you're pushing into the market. So what's sort of revving the motor these days?
Yes. What we have in Austin Powder is a really dynamic R&D and engineering team. As Marius said already, very customer-centric. So we're adaptable and ready to innovate for customer needs. Quite often our customers will come up with a concern that they might have or a shortcoming that they might have with either one of our products or a competitor's product, and we're always out there to sit with them, define that problem, and see if we can solve it for them. We'll be talking about it a little bit later, but we have bespoke products for different markets. We listen to our customers, what their needs are, whether it be the equipment they're using, the detonators they're using, the type of connectors that they're using on their products, and listen to them and try and implement solutions that are both suitable for themselves and us.
A lot of times I will cover a lot of other things, but this I want to jump right into it because I want to talk about eStar. Because I was looking through it, and it took me a while to understand what exactly was happening. I don't fully understand because it's kind of a whole system, right?
Yeah.
It's kind of an integrated system. Could you maybe give us that bird's eye and then maybe look at some of the segments? You have some really nice videos, and we will link those for people and even bring them up on screen here.
Sure.
You have some really nice videos on YouTube outlining how they work, but could you just walk us through it?
So I'm really glad you said system because we don't just sell a detonator by itself. We think of ourselves having solutions to problems. And we have various different detonator systems out there, from our entry-level eStar Go system, which is our smaller of our systems for small quarries, small construction jobs. And then we have our eStar Tunnel, which is very popular in our Scandinavian market. We sell tens of thousands or hundreds of thousands of detonators in that market. And we've got a very specific set of wires and connector set designed for that market. And there's an interesting story behind the design of that. Norway and Sweden are very sensitive to environmental impact when they're doing their blasting. So they want to minimize the amount of plastic and plastic waste that goes into their muck piles. They want to absolutely minimize that wherever they could or wherever they can. And we designed a product that is both lighter in the downline wire, or the leg wire that goes to the detonator from the connector down to the detonator, as well as a much smaller connector as well. How much smaller? It's about 6 times smaller than these connectors that you see in front of me now. So there's the eStar Tunnel, then there's also eStar Gold and Gold HD.
So they're physically different, I should just clarify.
They are, yeah. So the leg wire is different, the connector is different. What is inside the detonator shell, the copper shell of the detonator, so that's the explosives part of the detonator, is the same. But the interface between the detonator and let's call it the outside world, is different. So your leg wire is different, your interface of the detonator, so your connector. We also introduced RFID technology to make it much easier for our users to interface with the detonator. Yeah, so radio frequency identification. So each of our detonators would have a tag on the detonator very close to where the...
Could I see?
Yeah, absolutely. Close to where that yellow connector is. You can see there's a little connector there, and then just down from that there's a little flag tag. And inside there's an RFID antenna. And within that antenna is stored the serial number of the detonator. And it's really, really rapid for, especially in a underground high-speed development operation, to get the data you need from the detonator into the logging machine, which we call a logger, and then convert it over to the blast machine and get your blast on the ground as quickly as possible.
What is the old way of doing that? Because I was watching the video. They're taking, again, we'll be bringing these up on screen, so the audience will be seeing them. So they're bringing it up and they're bringing it to that, and they're just doing that. What's the other way it used to be done?
So they would have had to have interfaced directly with the detonator by placing it on top of the logger with the electronic detonators. If we're talking pyrotechnic detonators, there would have to be a physical connection between your either detonating cord or whatever they might be using in the application and the in-hole unit. So there'll be a physical connection. And again, with pyrotechnics, you're unable to test those detonators. With the electronics, you have the ability to communicate to the detonators they'll communicate back, and you'll be able to know that those detonators are good, working, leakage-free, and are ready to get fired when it comes to the time of firing.
Right. So, okay, so when you scan those, are you then, okay, is this system then, is it, that scanner, it's what exactly is it doing, and then where does that get fed to?
So the scanner, or the logger as we call
Logger,
it, is extracting the information either from the detonator or the RFID tag, and what it's getting there is the order of connection that you have. So let's say 1, 2, 3 up to 1600, which is our maximum amount of detonators on a single logger, but it's storing that sequence number as well as the serial number of that detonator, which it'll use later to communicate to that detonator. So that's stored in the logger, and once you've got your complete blast hooked up,
So you're almost inventorying it.
Correct, yeah.
Right, okay.
And then that information then gets transferred to the blasting machine at blasting time, and the blast machine will then, through interrogation of those detonators based on those serial numbers, then confirm that those detonators are actually there, ready and waiting, and correctly tested and ready to fire at firing time.
Right, so the difference is, at one time I would have had to go in, do all this connection. Now you're walking through and going beep, basically to the next one, right?
Yeah, and the timing design also plays a role. So in the past, you had to do the physical connection that Campbell was referring to, and have your timing based on how you connect them. Now we have electronic transfer of the timing. So once we have all those detonators and the serial number, we send a signal telling them when each one of you will fire.
I also saw as well is the configurations. Now I don't know if this is old or new. I was just looking through it. I saw one video that there's basically with this system there's any types of configurations, like you could merge daisy chain with, I forget the other term.
It'll be direct connection to the bus line.
Right, yeah, that's right. And you could do merge, you could do different, whatever configuration
you can have a hybrid. So what daisy chaining is simply connecting one connector of one detonator to the leg wire of another detonator like that. So just connecting it into the slot that's right there, and closing the connector, you make that daisy chain connection. Historically, what you would have had to have done is connect a bus line or a harness wire in each of the slots of the detonators hanging out the blast holes. So now you can actually, if you think about a tunnel environment where it's really hard to reach, it might be high up, you could connect 2 or 3 detonators together just using a daisy chain method, and then have the harness wire or the bus line run to your blast machine. So it just saves on harness wire or bus line on the face.
Right, wow. What is the R&D going into developing this whole system?
Well, we have a vast R&D team based both in the Western and the Eastern hemispheres. We do all the design on our detonator ourselves. This is the 4th generation of the E-Star. This detonator was first designed around 2001, so it's got about a 25-year-old track history. We've just released version 4 of this detonator, and we've integrated some great R&D work and engineering work there to make our detonator more robust against dynamic shock as well as EMP, which is electromagnetic pulse. We've done a lot of testing in the field in very harsh environments recently, and we've had fantastic results. So the work that the R&D guys and the engineering guys have done has really come to fruition. We've seen great benefits of the use of this latest product.
Does testing involve partnerships with the mines, or do you have like a test facility where you're kind of doing the field work first?
Yes to both questions.
Okay.
We do partner with mines, and that's exactly where we get a lot of our field exposure to real life conditions, but we also have laboratory and backyard conditions where we do test our detonators. Both in Europe and in the Americas as well. We have the facilities where we can initiate either detonators or detonators with boosters, so much larger explosive events, or we can go to our good customers and use their sites as a test bed to make sure that whatever we've designed and implemented actually works as we've designed it to.
This is just showing my maturity level, but I don't think I'd ever get tired of doing the testing of going boom. I think I would just enjoy it.
Well, and as Campbell mentioned, the backyard tests, we're unable to simulate every single situation we face in a mine.
Well, in different environments as well, right?
Environments.
Which I saw this is a very robust system for wet, cold, dry, even build up.
Hot.
Yeah, hot. Yeah. Mario, I was going to ask you actually. What is your focus then? Like systems like these I'm sure you're working with smaller mines too, but what's the focus for these big scale mines that you're working with?
So large scale mines require, of course, a tremendous amount of logistical coordination. So a supply chain is paramount to service a mine. So we target customers where we are a right fit in terms of logistics, in terms of personnel structure, and also, of course, safety conditions. Safety from the application perspective, and safety from just the surrounding environment.
Mm-hmm.
So,
what goes into actually putting one of these systems, though, actually going boom on a mine, on a large? I'm talking about these large operations.
Yeah. Thanks. Good question. We one thing we do as a company and have been doing for a long time since we went international is that we are set up locally in every country we operate. We have a local structure, understanding culture, understanding challenges, understanding idiosyncrasies. So we're able to select personnel and build up a team, Austinize a team before we target a customer, before we enter the market. We already have our safety culture, our standards, our operating procedures in place. So that takes time, takes investment. People to go train on the different tool sets we have, on the different systems that we have. So that's a big part of our division presidents, our business units identify how we're going to service the market, not just participate in a tender because it's a big project or looks nice. No, we have to be set up right, we have to be compliant, and we have to be safe.
On any given project, what is the mixture? Is it all different? Are you the one operating from the entire thing? Are some a mix? Are some you're just doing the supply to it?
So in the larger mines, the business models imposed by the larger mines, or I shouldn't say imposed, but the model they work with is they will have their own technical departments. They will have their short, mid, and long-term planners. They will have their own blasters many times, and they will design the shot as they're the ones having the geological information, all the core samplings. So they will be able to design the shot to move the material, the waste, away from the ore. We don't have access to that information.
Right.
So the way we're set up mostly in the large mines is we have a storage facilities, sometimes manufacturing on site, manufacture the emulsions on site, all the logistics, the MMUs, the bulk trucks, the magazines, and the personnel to do the service. At some sites, we'll do some or all of the QA, QC processes, verifying depths, verifying...
QA, QC is which?
Quality assurance, quality control.
Okay.
So it differs by mining operator, it differs by mine size, and it differs also by mining type, underground versus surface.
Sometimes I hear things and I think everybody else in the mining industry knows it, and I'm just late to the party. Okay, do you say they're manufacturing their emulsions on site?
Yeah.
Is that common?
It's very common.
Oh, okay.
Very common. The large mines, very common. Think about logistics. Shipping explosives would be much more expensive, troublesome.
So they're making the explosives on site?
Yes, sir.
Oh, okay. Wow. And so where's your role in that then? You must be...
We manufacture
You're manufacturing it. Okay.
Yes.
Yeah. So you come in and you essentially set up a facility.
We set up a manufacturing facility. Many times the mine will own a lot of the peripheral equipment, the tanks, the support equipment, compressors, boilers, other water treatment plants, whatever is needed. Then we come in and we set up our own manufacturing modules. It's modular plants that we can move around very easily.
Wow! And so the strategy changes based on what they have. That's what you were mentioning, the supply chain, right?
Yeah. The supply chain is key. Especially what we learned in the past 6 years with even before the Ukraine war, we had an event, a shortage of ammonium nitrate in the world. Then came the Ukraine war, and then COVID. All these three events really taught us a lesson on ensuring that we have a robust supply chain, and not only having a plan A, plan B, and plan C, but actually ensuring that those plans are actually in place, achievable. Because if you don't use your plan B to some extent, it's not really there.
Right. When you're going out to clients, where is the industry at in terms of education? I ask this question to a lot of different types of company, and I'm always curious. Where are they at when you show up at the door? Do they know what's going on? Is there a lot of education? Are different companies different? There's worker shortages and all that challenges. So someone's a manager who's only been in there for a few years, that type of thing?
You know enough about mining to know that a mining operation takes years to set up, and very, very large investments. So they of course know what they're doing. They know our business as much as we do, and that is something that is a fact. So education levels, you mean to
you're going to set up a processing plant. You're going to have a plan that's going to be put in place. You're bringing in all your tooling, like all that's going to happen. Is there a clear understanding of this generally in the industry now?
Yeah. So we have key roles identified that need to be part of that startup phase. So again, you go into greenfield project or brownfield project. Is it an existing project where you're just changing the incumbent, the supplier? Most likely you will change shirts for a lot of the guys.
Right.
So they'll have some training, and you'll just have to come in and ensure they understand your culture, your SOPs, your safety standards, what we call Austinizing.
Right.
And you will bring a couple of key personnel, especially on the.
But then you're having to plug people in.
Yes, you'll bring in.
Projects.
Yes.
Interesting. Yeah.
Yes, we have key personnel on the manufacturing side, and also on the MMU equipment side. Those are key roles that must be present, at least to get the operation ongoing.
Campbell, I want to circle back to eStar, and just, are there any projects that stand out? It's nice when we can kind of make things real, like the real world application. Are there any projects that stand out to you that really you thought really exemplified your expertise?
Yeah, actually, Maury and I were discussing this a little bit earlier about how we're going to answer that question. There's so many. Which one do you look at?
Right.
We've got a lot of experience in proving the benefits of electronic detonators at an end user, and one of the obvious ones that comes to mind is some of the tunnel work actually we've been doing in Scandinavia. A lot of those customers are completely reliant on the use of electronic detonators to continue their contract. And why they're using electronic detonators is because the detonators are accurate and testable, and resilient and reliable. So you want to make sure that you got a detonator in the hole that's going to fire at the right time every time. And one of the constraints they have is vibration. So there's a lot of built-up areas. There might be oil or gas pipelines very close to where those tunnels are getting developed, and perhaps even in suburban areas. And there's a lot of risk of damage to buildings, to pipelines, etc. So we've got a lot of experience and quite a few benefit studies published on the use of our tunnel product, especially in the Scandinavian perspective. Some of the other projects we have is the eStar Diamond product. I want to talk about that a little bit more. What the Diamond product is, that's our flagship product that has three key areas where it has additional features over our eStar HD or our heavy duty product. And that is, it has the ability to measure temperature within the detonator shell, and that's quite unique in the industry. Also, it has a 40-second timeout, so a maximum delay of 40 seconds. It's actually extendable more than that, but we currently have it set at 40 seconds. And then thirdly, we have the highly visible and double insulated pink leg wire. So that distinguishes us from some of our own products as well as some of the competitive products. And we've done some studies in the Mexican markets where we've proven that there's a lot to be gained by knowing where you may or may not have reactive ground. So you have some holes in certain areas of the pit that are reacting with the rock and with the explosives that's in the ground. And you may be able to identify certain risky areas over others that aren't so risky. Just by using the E-star diamond with that temperature, call it probe the thermometer within the detonator shell. And what that gives you is the ability to take the data, take that information, put it into our Paradigm software, and what we envisage is our customers using Paradigm software to simulate, to emulate what the future might look like for certain benches as you expand the mining limits or the pit, and also just learning about history, have all that historical data about where you might have had hot pockets, what the geology was in those areas, what geology wasn't for that matter, how long those holes were drilled for, was it reacting within a day or a week or a month. There's a lot of information that you can gain from the use of that. So it's one of our new products.
Paradigm is the software package?
Paradigm is the software, Paradigm is the software package. And I think one of our previous interviews that you did with Cameron McKenzie and Alan Rumpf actually spoke about that in great detail. It's one of the features that we are going to be integrating into Paradigm at some stage, is the ability to use the information that's coming out of the E-star diamond product and doing those simulations.
Right.
And for a little bit of context there, this is big from the safety perspective. There's been incidents in many mines around the world where a loaded hole detonates on its own without any warning and without, of course, wanting to. And this is because that reaction gets to certain temperatures, high temperatures, that the primer, the explosives primer, the booster, actually detonates and initiates the column. So it's a huge safety concern. The other safety concern, or the other cost concern for the mine, would be today mines where there are reactive grounds, they have to introduce some sort of method to cope with that, whether that is sleeving the holes or using inhibited product, which is more expensive. But if you now are able to map out your pit and have a much better understanding of where your reactivity comes from, then you can select where you're going to load certain holes or certain products, or when you have to shoot a particular shot or a particular hole because it's getting to that threshold of safety.
How much better is all that now than it was even internally, like 5 years ago, 6 years ago? Like how much has your technology advanced, do you see?
Leaps and bounds. 5 years ago, something like this was just not available.
Right.
And that's, again, back to what we spoke about when we first started, is
the
R&D, and we're the R&D guys are always chomping at the bit for a new project. And if we come up with a new idea, or a customer comes up with a new idea, says, hey, could you please try? And the guys are right on that. They want to do it right away. So there's a culture of innovation within the company that is always there.
R&D, is there some element of localization to it, or is it a one hub? How do you approach the R&D? Just the logistics of it, the setup.
It's quite a global effort. Our R&D director is based in the US. However, we have R&D centers within other areas in the US away from the R&D director's central office. And then we also have a center in Czech Republic, actually, that has a large R&D section that concentrates on pyrotechnics, on electronic detonators, on equipment design, on manufacturing, etc.
Mario, I want to go back to the question I asked to Campbell, and the same to you. Is there a product to you that stands out that you went, this really does exemplify what we deliver?
I didn't think you were going to ask. Thanks. Yeah, we just came up. We just started production, full scale production in Argentina, and are in the process of building or finishing building the plant for full scale production in the U.S. for what we call our Helix booster. The Helix booster is a TNT-free booster. That means we're getting rid of a very hard to import raw material, costly. Today, with the military activity around the world, there is no availability. But most importantly, it's a nasty, environmentally speaking product. It's very dirty in the production side. We're also able with our Helix product booster to fully automate the production. So we're taking 100% of the personnel away from the danger zone. So it's completely remote. And this is a first for this type of product.
Sorry, when you say automate as opposed to, could you just give me the comparison?
Manual, as opposed to manually pouring, having people inside the manufacturing facility.
Right. So where is the pouring done then? Is it done?
It's done in a closed building and monitored remotely. When I say remotely, I'm talking 100 meters away.
Oh, it's like a manufacturing pour, like it's an automated system.
It's an automated system.
Oh, I see. Got it. Yeah.
But up to now, people are in front of
the
explosive.
Okay.
So now we've taken complete presence of anybody when there is production.
So is that being designed also on site then? That's being made, that automation system, or is that?
No. We have that now in Argentina.
Oh, okay.
We are finishing building our manufacturing site in the U.S., in Ohio. And the next will be in Europe, definitely. Not sure exactly where, but
right.
Upcoming.
So that automation system, and then would then deliver to site.
Then deliver to the customers
Okay,
or to our distribution sites.
Right.
So this will be a product that will have a long enough shelf life. Today, cast boosters have indefinite shelf life. This will definitely have a shelf life, but it will be a lot more than what you would like to keep explosives in storage. It is from the use and feel perspective, it's the same product. From the performance perspective, it's the same product. It's just so much safer in-house production, and also you're taking away, again, a product that is not the best environmentally speaking.
And that is being rolled out, you said, into Argentina. That is
Argentina is already in full-scale production.
Right.
U.S. will be by the end of the year, before the end of the year.
Yeah, and then so that's Argentina, that is getting delivered to a mine site then?
From Argentina, we deliver to all the different customers, whether those are mine sites, quarries, or cement plants, construction sites too.
And what is a mine? I mean, that's a big deal for a mine, I would imagine. To say, okay, we're eliminating a danger zone.
We hope it is a big deal for them.
Yeah.
We hope it is, because it ensures that our supply chain is guaranteed. As there's been a couple of recent events in manufacturing of that particular product, very sad events where a lot of people got a lot of fatalities.
I see.
So this project, we've been working on this for over 5 years. It was not easy, but our Argentinian team really took the flag and ran with it. So we hope it is important for the mines that we're taking an environmentally dirty product out of the market, and also that it's a much safer operation.
Do you see something like that becoming? Both of you, I'd love to answer. Innovation is something like that. Does it become 5 years from now? Does that become industry standard? Is it, or is it exclusive to you, hard to replicate? Like, you know what I mean? Like, new innovations sometimes become, okay, well, that's the way we have to do it now. Is it that type of shift, do you think?
On the Helix side of things that Mario has mentioned, I think we're perhaps ahead of the curve as far as developing this product and getting our facilities running in Argentina and now in the US as well. Will it become the standard in globally at some stage? It all really depends on what our competitors decide to do. And
this
also,
is really giving you, you're looking at this to really give you an edge then?
Definitely an edge, and the supply chain may force our competitors into this decision or some other similar
that's
solution.
That's what you were talking about earlier, yeah.
So again, this
it's just an interesting. I just find it interesting. That's why I'm kind of going in on it. So.
We're competing for this raw material with the military forces of every country in the world.
Right.
So this is what is the TNT is what is mainly used for military application. So right now, everybody's building up. Sadly, but it is.
Yeah.
It is a fact.
Yeah.
So there's no availability for commercial application.
As the demand for mining also goes up.
Exactly.
Yeah, yeah.
Exactly. So Campbell is right. We think we are ahead of the curve.
But the
on this.
demand may force
Yes,
the innovation.
Yes, it will. It will.
Interesting.
And hopefully sooner than later, when all this military activity, winds down, there'll be a lot more available. But we won't take it. We're not going back as a company.
Right. Yeah.
From the environmental perspective and from the safety of our people. Again, if we use TNT, you almost certainly have to have people exposed.
Right. Yeah. It's. I have to say, what I was thinking about as we wrap up this interview is sometimes people go, well, we'll do the show once. In your case, this is your 4th time, Austin Powder. Every episode is different. And like this is information that I just did not have from doing other previous episodes and seeing the other. I don't think I've done all the interviews, but some of those other interviews that I've seen. And that's the uniqueness of the show. When you get 2 different people, they're going to come from a different perspective, and you kind of dig in. It's that expertise. So just thank you for coming on the show, sharing, and just kind of walking through it. It's quite fascinating to get to these layers of a company as you get to have them on more and more.
Let me give you one close to home.
Please.
We're setting up right now to start a very large project in New York City.
Oh.
The expansion of the metro there. And we've just received
Right.
the first approval to load bulk explosives underground in New York City. And the East Star Tunnel that Campbell was referring to and Paradigm will be the system used to drive that. So
Wow. Well, we do on site. If you want to get someone in there to get cameras on anything, let us know, because that'd be amazing. That was actually, I was thinking that also on the interview. I was like, I'd love to get on some of these sites, like actually see the facilities you got. It was just amazing. Some of the stuff you're doing.
Let's do it.
Yeah. Thank you very much, gentlemen. I hope we do this again. I really do. Thank you for doing the show. And yeah, I'm excited to see the audience response to it.
Thanks, Jared.
Thank you, Jared.
Thank you.
Thanks for having us.
Yeah.
And thank you, everybody, for watching. We'll put both gentlemen's LinkedIn if you want to connect with them. Of course, we'll have Austin Powder's YouTube. They've got some very good YouTube videos, so go check those out. Their website, their LinkedIn. Make sure to follow them. And follow us if you haven't. We're always bringing in new guests, so if it's the first time seeing the show, please follow. And we will see you on the next episode of Mining Now.